Hi everyone. In today's session, I would like to discuss operations carried out using milling machine. So this is your continuation to the last class. So after this session, you will be able to know what are the different types of milling operations and what do you mean by peripheral. So milling operations are described and based on the SRT categorization of milling, and these were differentiated on basis of relative position of milling cutter. And the following are the operations that are performed using milling. So first is plain milling operation, face milling operation, side milling operation, straddle milling operation, angular milling operation, gang milling operation, form milling operation, profile milling operation, end milling operation, saw milling, slot milling, gear cutting, helical milling, cam milling, and lastly thread milling. In your laboratory, you have personally experienced how the gear cutting operation is done. So first we shall discuss each one. So first we are going with plain milling operation. So this plain milling operation is used to produce a plain or flat or a horizontal surfaces, and this is also called as slab milling. Okay, here the face milling is cutter is used. So you can see the diagram of the face milling cutter. Okay. And next is face milling, continues with that, which is used to produce flat surfaces on the workpiece. The surface is perpendicular to the surface prepared in plain milling operation. The operation is performed by face milling cutter only, mounted on stud arbor of milling machine. Okay. Next is side milling. So in the name mentioned, it is the operation produces flat and vertical sides of the surface of the workpiece. In this operation, depth of cut is adjusted by vertical feeds. So this is the schematic diagram of it. Next is straddle milling operation. This is similar to the side milling operation. Here, two side milling cutters are mounted and the same arbor. So in the arbor, you will be having two milling cutters, and the distance between them is adjusted based upon the workpiece and to be milled. So in this, by using this, we will be producing hexagonal bolts. Okay, and this operation is two parallel pieces of bolts simultaneously. And the next is angular milling. Sorry, in this angular milling operation, which is used to produce angular surfaces on the workpiece. So the producer surfaces makes an angle access to the spindle, not to the right angle position. Okay. And next, the gang milling operation. And the name itself indicates gang. Several surfaces of workpieces can be manufactured simultaneously by using of gang milling cutters. Next is form milling. So here you can see the form milling. The workpiece is held with respect to the milling cutter, which consists of irregular counters, which is used to produce a convex or a concave shape. And this is comparatively low cutter speed and then plain milling operation. And the next is profile. So in the name itself, the profile means it is particular desired shape. So here we will be using a master die. Based upon the die master, we will be producing the operation. A tracer and milling cutters are synchronized together with respect to their movements. And here the profile milling is an operation to generate produce template or die, like the casting process. Whatever we can, like that we can produce. So I hope everyone is clear with all the operations. So next is end milling operation. In the end milling operation is almost like side milling, which is flat vertical surfaces. And here flat horizontal surfaces also can be produced. So on the table surface using for milling cutter is name itself end mill. So this is for carried out for vertical milling machines. And next is saw milling. Saw operations is used to produce narrow slots or grooves in the workpiece. This is used to produce equal and unequal lengths also. And these are cut into parting out In case of parting of operation, cutter and workpiece are set in a manner. The cutter is directly placed over the one slot of the table. So this here schematic. And next is slot milling, which is used to produce a key-based grooves of slots of varying shapes can be produced. So here the cutter tool depends upon type and size of the grooves required. So the gear cutting operation I need not explain because in the laboratory you really perform, everyone has performed. Okay. In this operation we can also using milling machine thread cutting operation also be done. Next important term is peripheral milling. So for peripheral milling is an operation to produce machine surface parallel to the axis of rotation of cutter. Here the cutting force is not uniform throughout the length of the cut given by the tool. So the quality of surface generated and shape of the chip depending upon the corrective relative direction of speed of momentum. So this can be done in two kinds, up milling and it is also called as conventional milling and in another is down milling. Here we can see the diagram, conventional up milling and down milling. So the main difference is in the conventional up milling, the axis direction of rotation of cutter and feed are in clockwise or in the same direction. Whereas in down milling, the feed will be in the opposite side to the direction of cutting or rotation. This cannot be used to produce backlash powder. Okay, this is used for only down milling is used for only finishing operation. This result in surface finish. Okay, so this is the main difference between up milling and down milling. Up mill will be having a lower surface finish when compared to the down mill. So some important questions.